a Oracle database server. It's a server, right? See, on Oracle database server, when I say Oracle is installed and up and running, what is the meaning of that is a Oracle database server is made up of two important components. So broadly, one is called as Oracle database, other one is called as Oracle instance. Where is the database? Where is the instance? Database is on the storage. I was telling database physically is just files. It is only files on storage. But as we all know, we cannot directly read and write from the file. We need programs or the processes. A program in execution is called as a process, which runs in the memory. There is a process which runs in the memory, which will help me to read and write from the disk. Okay, without a program, without memory, how can I read and write from the disk? So I need processes running on the server, which will help me to access my storage, access my database. And it's not only the programs, you need memory. You cannot directly read from the hard disk and give it to the client. The data has to be read into memory. And if many changes are happening, the changes will first happen in the memory, and the changed data has to be flushed to the disk. That means we need to read the data from disk into the memory, and from memory, when there is a change, it has to be written back. And for all reading and writing and many other purposes, we need different programs running always on the server. Those are called as background processes. So there are two parts in a Oracle database. Let me again go back. Okay. One is database, which is files on storage. So this much. Then to access these files, we need instance. Instance runs on memory, RAM, random access memory or main memory. The instance runs in a memory, and through the instance we access the database, which is on the storage, which could be local storage like my laptop. On my laptop, I have Oracle instance running in my memory, and in the local hard disk, I have my database. Or it could be shared storage. Storage is on a network. Okay, anyway. Okay, local storage or network storage. Okay, local hard disk or network storage. Okay. So, but this instance is again made up of two components. One is memory structure. It is a memory to hold. And what to hold? You need your select statement also to be stored, yes or no, which is called as code. I will call it as code. Not only select statement, PL/SQL block or Java program. So you need some space to hold the code. I just call it as code. Code could be a simple SQL statement or PL/SQL block or Java program. And there has to be structure to hold data rows. Data is different from code. So we need memory structure for both. So we need different types of memory pools for different purposes. That is called as memory structure. The instance is made of memory structure and background processes. Okay. And also this memory structure, there are two types actually. One is called as PGA, which we will take it a bit later, or currently will not. This is called as process global area or program global area or private global area, which we will talk about it a bit later. Don't worry about it now. But here this is important. This instance has something called as system global area, also called as shared global area. I will call it as shared global area. Why it is called as shared global area is, this is common for all database users. There are multiple database users connected. This is common. So this is common area available to all the database sessions. Whereas every database session will have their own private PGA. PGA is private to each session. SGA is common for all the sessions. So a Oracle server is made up of database, which is files on the storage, and it is made up of instance. Instance itself is made up of memory structures, which is called as system global area, and the background processes. Why do we call it as background? Because they are running on the server side, not on the application server or not on the client machine. And they are always running, whether if you give work, they do work. If you don't give any work, they are idle. Idle process means a process which doesn't have any work as of now. But the moment you give a work, they start working. So you need many background processes always running. And some of them are mandatory. Without them, you cannot run the database. If the process crashes, the instance crashes. And the instance crashes, database is down. So I repeat again. So on the Oracle server, you have database on the storage and instance. So the only way to access this database is through instance. Okay, without instance, we cannot access the database. Just I'll just give an example. You have a MS Word file physically on your hard disk, but you don't have MS Office installed. How can you read? Now you need MS Word software. First you have to run the MS Word software. Then there you go file and open. So instance is like that. Instance is the one through which you access the database. Okay. So through instance we have, and this is on the server side. All this is on the server side. Now up to from here. All anyway. This mark is like this. All this is a server side. On the client side, assume that application server or client server directly. So assume that application server, let us work. So I'm using SQL Plus or SQL Developer as a database user. I want to connect to the server. A client using some program. It could be ProC, ProCobol, Java, or SQL Plus. User also will have something running here on the client machine, through which the user will connect to the server. So the program which is running on the client machine is called as user process. Like, let us not get confused, SQL Plus, which is just a lightweight .exe file, right? Through SQL Plus, I will connect to the server as a database user. Okay, so here SQL Plus which is running on my local machine is, I don't have Oracle installed on my laptop, but I may have only just the client installed. So this is the user process. The moment a user process successfully connects to the database, successfully connect means what? The database user exists, the password is correct, you have all the privileges to connect. The moment you connect, connection is through, it is called as one session, one database session. So what is an Oracle session? The Oracle session is a successful connection to the database. The moment a session starts, for every session by default, one server process starts running on the server. And its job is to only service this session. So it is only waiting for the command. Here I say select, it is given to the server. I say insert, it is given to them. I say create table, it is given to them. So this server process is to interact with both Oracle instance and the database and get the client's request executed. So this is the job of this is called as dedicated server process. It is dedicated to this particular session, and every session has a PGA, private global area, process global area. In the diagram is only one session shown. Some other client also will connect. Again, same thing will be there. So naturally, multiple database sessions will be there connected to the database. Every session has its own server process, its own PGA, but SGA is common for all the sessions. SGA, we will discuss what are the components of SGA as we proceed. So this is a very, very, very high level first information about Oracle database. The Oracle server, Oracle server is made up of Oracle database and Oracle. What will happen if the instance crashes? It will not be able to access the database. Very simple. The database is down. Or a disk crashes. Your database is down. Instance is running, but what is the use? Disks are crashed. But how do we protect from failure? Even if the instance crashes, see, all production database like banking database and all cannot afford to be down, right? They should be up and running 24/7. So this diagram is called as this. We'll go to the next slide. You can observe here, or this one only. So if I have simply a single server where I have my Oracle instance running and I have my storage, it's fine. But here we have three problems. One is fault tolerance, or is not high available. Why this diagram, the setup in this diagram is not high availability? Because instance crashes, database is down. disk crashes database. So that means not fault tolerant. Apart from that, it is a problem for scalability also and also performance. Because now assuming that we don't have crash and all, instance always assume that. But the problem is a single instance as the load increases, you have new applications coming up. No, it's a lot of database, number of database sessions drastically increasing every quarter, every year. So the server, and anything we increase the resources on the server, number of servers, memory, but that is called as vertical scalability. You can increase the resources up to only one point. Then it starts as when the load is too much, you will have performance issue. And that single is not scalability, doesn't offer scalability. So scalability, performance issue, because there is a single server has to service everything, right? So once it reaches peak, what will happen to the new application? Where do you run? In this training, we will be talking about only this, but as we so this has all the three problems: high availability, scalability, performance. So Oracle offers, I was telling you, there is another separate training program called as real application cluster. So what happens here is, instead of depending on a single server running on only one server accessing the database, Oracle says you have one server, let's make one instance run here, and that instance accesses your database on a shared storage over storage network. Have another instance running on another server. Third instance, these are called as nodes, node 1, node 2, node 3. Every node will have a Oracle instance running. Multiple instances running on different nodes, but all of them access the same database on the shared storage. Now this offers instance level high availability, instance level performance, instance level scalability. Why it is scalable? Now I am having 3 instances. Now the load is increased. I can add one more instance. 4th, 5th instance, 7th, 6th instance. The load has come down drastically, my business is down. I can remove instances. I can add instances, I can remove instances. So they are scalable. And performance. It's not that all application gets connected to only one instance and then some applications are connecting here, some applications are connecting here, some applications are connecting here. So the load is distributed across multiple instances and hence they perform better. But all of them access the same database. So that is called as real application cluster or clustered database, which offers high availability of the instance, high availability, performance, and scalability. So we need to move to RAG. So what is that? How it is high availability? Now the session database sessions are accessing through this instance. If the instance fails, all the sessions which are accessing the database through node 1 will be transparently redirected to the other node. Load sharing. And 2. So my session is connected through this. Because this is failed, my connection will be redirected through this. But ultimately, I am accessing the same database. So you need to have multiple. But if you lose all instances, again database is down. But chances of losing all the instances at the same time is rare. But that can happen. All are in one data center. And there is a fire or flood in the data center. Then what we will have is we will have a similar replica in another geography, another country itself. That is called as data guard. This is for instance failure only, not for data center loss. But we will have data guard. That I will not get. This is my primary database. The event of this entire thing is all here. The standby, we call it a standby database running on other countries, will become primary. So to that extent, Oracle supports high availability. So this is currently what we discussed is just an overview. It is not a RAG training, but still you should know what is real application cluster. So that is fine. So now this RAG, cluster system protects us from instance failure. But what will happen if the disk fails or disk fails? All instances are up and running, but the disk is failed. Disks are failed. Crash. Again, the database is down. So to protect from protect and scalability and performance of the disk, there are many techniques, many technologies. I mean, but from Oracle side, Oracle use something called as ASM, Automatic Storage Management, which gives you striping and mirroring. This is not shown in the Oracle slide. I'm just explaining. Striping and mirroring. So see this mirroring. There are two ways of mirroring. Two-way mirroring, three-way mirroring. Three-way mirroring is the good one. 3 copies of the data. 3 copies. So if one is lost, no problem. Second is lost, no problem. Third is there. You can go for two-way mirroring or you can go for three-way mirroring. So we should use ASM and have duplication. I mean mirroring should be there. That means I have 3 hard disks. The same data is stored in 3 hard disks. If 2 are failed, I don't have any problem. But ultimately, if all 3 are failed, the database is down. But if this database is down, there is no problem. There is a standby. It is waiting for this to be down. The moment it is down, that will take the role of the primary. Meanwhile, we can recover this and again switch back. This concept is called as real application cluster and ASM. ASM is to what is this typing is we don't want see this is the hard disk. If all the data there is a file, no huge file. The file is on only one disk. What will happen is there will be a lot of people accessing that file. Different parts of different rows in the file. You get disk IO congestion. Every disk has a limit of servicing IOs. It cannot exceed that. The moment the requests are more than what it can service, you get congestion or bottleneck. The performance degrades. So what this ASM does is, I will have multiple hard disks. Hard disk 1, hard disk 2, hard disk 3, hard disk 4. I stripe my single file across disk. One file content is called as striping. Now think of this, one huge file having in one disk versus the same file is now striped versus in multiple hard disks. Here all IOs are on only one, but now here some IOs are here, some IOs are here, some IOs are here. See, the IOs are accessing the data through different disks. This improves performance, which ASM provides. ASM provides striping of the data across this. ASM provides mirroring. Just an overview. So I will keep a tab on the time also as we go. So because I don't want too much theory in a day. At one time, no, I'll stop, I'll show you some hands-on. Hope you are able to hear me and view my screen as of now.
Yes.
Yeah, thank you. So I will proceed. If there are no questions, I'll assume that you are fine. But if you have questions, please stop me. This we have mentioned already, but quickly I'll show you through commands also, through hands-on also. So what is a database session? A successful connection from client to the server is called as one database session. The session will have a program running on the client, which is called as user process. And for every connection, there is a dedicated server process. Why called as dedicated is, you have connected, but you are not issuing any command. The server process is idle. Its job is only to service that session. Just because it is idle, it cannot service other sessions. Okay, typically this is the default architecture, which is good for performance. Okay, so this is called as a database session. So now, as a DBA, I want to know how many database sessions are connected to the database as of now. So what is that? What is the name of the database user? All that we can explain. Now, we were talking about SGA, right? System Global Area, or call it as Shared Global Area, which is common to all the database user sessions. But that in turn is made up of different memory structures or pools. Okay, different. And there is a PGA. So you can see here there is only one SGA per instance, but every session has their own PGA, Program Global Area, which is called as private to the session. That means what? This session cannot access this. This cannot access this. But all of them are accessing this. This is common. Private and common. That much is okay currently. We will come back on which state pool, what is each of the purpose of the pool. And all these pools are in the memory and it is part of instance. Okay. But before we get into instance, actually this sequencing is not correct, Oracle sequencing. No, Oracle, from Oracle point of view, it may be correct, but from my point of view, they are not that correct. First what we will do now, we will take a look at the physical structure of a database. Physical means what? What all files makes a database. Put all files together. So these are the files which is on the storage. These are the files on the storage, on the disk. All these files is called as Oracle database physical structure. Okay. And to access these data files, we access through instance. Instance has memory structures and background process. But we will quickly take a look at this, then only it will be easier. So, can you tell me what is control file? I know if you are new to, no, you may not be able to answer just like that. What is control file? What is stored in control file? What is stored in data file? What is stored in online log? What is archived log file? What is backup file? What is this file? What is that file? We will discuss all this. So what I'll do is I will go to the MS Word document and discuss. Just give me 1 second time. I'll just have water and start. Okay, can you hear me? I am back.
Yes.
Yeah, fine. Right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, fine. That's clear. So now, please stop me in case you have any question. So first we will start with the data file. This fan is making too much of noise. So we'll start with one by one. Anyway, we'll go to the PPT as required. Data file. So as the name indicates, data files. A database will have hundreds of files, or few files, multiple files. The data is stored in data files. But data means what? Rows. And rows are stored where? Tables. Right? So we insert records into the tables. The tables are stored in data file. Or we can say data file contains rows. Data. Actual data is stored in data file. This is very important. But directly the rows are not. Rows are stored inside the table. The tables are stored inside the data file. And these tables are of two types. Okay. Application and user tables and system tables. So can you give me an example of a system table space? Say customer is a user table space. Customer, order, sorry, what I wrote, order, order, invoice. Like these are the application of user, we create them. But there are lots, the moment I create a database, Oracle implicitly creates lot of tables, which are called as metadata tables or system tables. See the word system tables. System means Oracle creates and Oracle maintains them. We only query. So have you checked any one of the data dictionary? Or can you tell me, how do I know, as an ordinary user, Scott or HR or some user databases are connected? How many tables are there in my schema? My schema means my user, database user. For that, we run something, select star from user underscore dash dash dash. Purposely I will not put a semicolon. What is it? It tells me, I want to know how many tables are there first, right? User underscore, any idea? user underscore tables. So all the tables that we create as a user, the metadata Oracle has to maintain, right? I create a customer table and entry will go to user underscore table. I create a order table and entry will go here. I drop the table, entry has to be removed. So these are called as metadata tables, are also called as system tables, which Oracle has always, and Oracle maintains them. We only query them. And we can only query. We cannot do insert, update, delete on them. So those are also tables, ours are also tables. But is it good to mix those into the same data file? Or should we keep Oracle supplied tables separately and from user supplied? Just like in a laptop, assume that which is the good scenario, can I have only C drive? Assume that I have a laptop. I have only one drive, C drive, where OS is also installed and all other my important data applications are also on the C drive. Is that best configuration or not? Or should I have C drive only for OS and D drive and E drive, F drive for different purposes? Should we mix our data with OS where the OS is installed? Is it good to mix or keep OS separately in C drive? C drive is exclusively meant for only OS. Is that better configuration or should we everything have in only one drive? Obviously, we don't want, right? So OS crashes, we will give it to our ING person. They will only format C drive and install OS without touching other portion. Similarly, what we do now, even though the data file contains tables, we don't want to mix the Oracle supply tables with user supplied. So that is the reason I was telling you something called as table space. There is a table space called as system table space, which is again data files only, which is made up of data files, but this is exclusively for system tables, or also called as metadata table, Oracle supply table. We don't want to mix our tables. Then, say for example, talent transformation TS, payroll TS, payroll. Now say for example, travel, all travel application, travel TS. So these are table spaces. Again, table space is made of data files. Again, data files are made up of tables. And tables are source. So here you can see that all these tables belong to talent transformation application. These tables will belong to payroll, like this, data file. So we don't want to mix up system with users. Again, users, we don't want to mix up everything. Each application or each module, we may want to have separate tables. See, I have not mixed talent transformation with payroll. Payroll is high priority. Comparatively, I mean everything is high priority comparatively. So if I want to take this table, this offline, I can take only this offline without affecting others. But if I don't separate, organize it like this, assume that I have mixed up talent transformation, payroll, travel into one. I want to take only travel offline. I will not be able to take. If I will take everything offline. So this is how, see, ultimately data files are there, but data files are well organized to table space. That in a database, I'll repeat again, in a database is made up of multiple table spaces. Multiple table spaces. And each table space is made up of multiple files. Database, right here. A database is physically, table space is logical, but which is actually made up of multiple data files. So we may want to have multiple table spaces. One is we don't want to mix up system with users. Again, in users, different applications, different modules may be in different tables. So this is what is your ultimately the data file. So the enterprise data actually sits, even the metadata tables, user tables, everything is stored in data file. So a database is made up of table spaces. Each table space is made up of multiple data files. That means the database is made up of multiple data files. So now, and data files, what is stored in data files? Rows inside table. So this is what is data file. So any questions around data files? But a database will have multiple data files. One. So there is another type of file called as redo log files. Redo log files. This takes a lot of time to explain, and we repeat all this. In a database, so now before I go to, I have database which is made up of files, and I take backup of the file. I say backup of data file. Fine. So these are called as backup data file, which was there in the slide. It's a copy of the data file. But the thing is, every day I take backup at 9 p.m. in the night. Assume that. So yesterday night I have taken the backup at 9 p.m. Fine, no. But today my data file crashed, got deleted. At what is the time now? 6 p.m. Just assume that. But my backup is yesterday's backup. I can restore, but what will happen to the transaction that I have made from yesterday night 9 p.m. to right away evening 6 p.m.? Where are those transactions? And I cannot take backup every second, right? Or assume that I have taken backup at 2 p.m. today itself. Now it is 6 p.m. At 6 p.m. all data files got deleted. If I restore my backup, I will get all the data that is there at 2 p.m. But what about the 4 hours data? Last 4 hours data. Where is it? It is important for me. So that means just backup is not enough. There has to be another mechanism where every change is stored. So for that is called as recovery process. The backup is there. Backup has to be recovered. Restoring is one part. Recovery. That means whatever changes we are making, the changes will go to the table in the row. That is one place. But just writing to one place is not enough. That same thing has to be written to the other place. That is called as redo log file. Redo log file. Redo. See the word redo. When do you redo? Whatever we have done is lost, so we redo it. That is called as redo log file. So every change, it could be inserted, is recorded in redo log file. So now, and these are called as, there are two types of redo logs which I will cover as we go on. Online and other one is archived. I will cover that bit later. Archived redo log file. One second. Archived. Online, because they are redo log file. That means whatever change you make, they are recorded. Now the same scenario. Now I have taken backup at 2 p.m. At 6 p.m. all my data is lost. All data files are lost. No problem. I'll restore my backup at 2 p.m. and whatever changes I'm making from not only 2 p.m. everything is there, but the changes made from 2 p.m. to 6 p.m. it will be there definitely. And we apply that. But to start picking from 2, I don't need the changes before 2 p.m. because I restored my backup. My backup was taken at 2 p.m. I apply the changes which are there in my redo log files. Let us forget about this redo log file. Every change is there, but I need changes only after 2 p.m. till up to the point of crash. Apply it, everything is as if there is no crash at all. This is called as restore and recover. And to do the recovery, you require redo log file. Those are redo log files. But there are online and offline. That means what? First we write to online redo log file. When it is full, it is archived. So there are two types, online and offline. Online. So as the change is happening, it is first returned to online redo log file. And that is gets archived. Once it is full. So online redo log file, what is the major purpose of this redo log file? As we go, we will cover in depth. Just I'm not going purposely in depth. There are two purposes. So 3 purposes actually. I will tell you one by one. One I will not explain. One is called as fast commit. This I will not explain now. I'm just mentioning. The purpose of redo log files is for fast commit. Other one is recovery. And there are two types of recovery: instance recovery and media recovery. Media is hard disk crash, data files corrupted, data files lost. That is media. Instance recovery is only the memory is lost. That means there are some committed changes which are there in the memory yet to be returned to the disk. Those is called as instance recovery. Instance recovery means I have inserted one row and committed. They say insert, one row is inserted and I committed. So once I commit, as per me, the data should be there, right? But what happens? This committed row is still in the memory instance, not yet returned to the table. Now the instance crashes. But I don't know. I have already committed. My data has to be there. Again, the redo log comes into picture. So redo log helps us with two purposes. Instance recovery, instance and media recovery, and fast commit. Fast commit we will take up to later. So what we talked about, what is data file, what is redo log file. But a database is made up of too many data files, many redo log files. When I start up as a DBA, I start up my database. All these has to be opened. So it has to keep track of how many data files are there, where they are. How many redo log files are there, where they are. There should be one file which has information about all other files for it to open, right? So as a DBA, I will not be opening every file, right? I just give one command startup. So the moment I say startup, it should open all the data files and all the redo log files. How it will know how many files are there, where they are? How many data files are there? How many redo log files, where they are? So all that information is stored in another very important file is called as control file. Control file keeps track of info of all other files like data file and redo log file. Redo log file. So once Oracle opens the control file, it is easy for it. It knows there are 100 data files across these days. This is the path. These are the redo log files. These are the data files to be opened. These are the data files. So when I say start up the database, first it has to read the control file. Only after reading the control file, it will come to know how many data files are there, where they are. Open those data files. How many redo log files are there, where they are. Open those. So for that, you should know control file. So control file is a small file having only the path, file name with path of other for it to open. So that's one. But not only just it's not like that, no. Data file, some C drive, just like that, some folder. This is the data file 1.dbf. So some D drive, some other folder. Okay, data file d2.dbf. This information will be there in the control file. How many data files are there? Where they are? This information is stored in the control file. So when the control file is open, it has to open this data file. It has to open this data file. Now it knows that it has to open these two data files. But it is not only just the data file. What may happen is, actually this file is lost. This is the current file, current file. Okay, I have the backup of this 2 days old backup. 2 days old backup. I have the backup. So the current file is lost. What I'll do is, I take the backup and put it here. And control file is opens it, but it is opening a old file, not the current one. So it is not only exists, it is not only just checking. See, I'll tell you, I'll remove it. So when I start up the database, it will read the control file. After reading the control file, it has to open data file D1 from this folder. So it will go and open up. It will open this. It is not just looking for a file with this name in this folder and just opening. After opening, every time it opens, you should check. Is this latest, up to date? How to know is the consistency? It may be a restored one, old one I have restored. Actual file is lost. I took the back from the backup disk, I restored with the same name in the same path. It is not just looking for a file with same name and file same path. Anyway, that is there. Once it opens, it should read the header of the file to check is this latest or not. That means that information is stored. That is called as SCN, system change number. So what it does, it says that data file D1, when it is opened, the SCN has to be some number. data file 2, when I open the SDN has to be like this. It is not only just opening data file D1. After opening, the header should match what is stored in the data file. So in the data file header, this is the data file. Header also the same number would have been stored here. Control C, Control. So from the control file says data file to be opened. It will open data file. After opening, it will cross check. Is the SDN matching? STL recorded in the control file for the data file actually with the data file header. It's recorded header. STL is recorded in two places, the data file header as well as control file. So we cannot fool Oracle by putting some file with the same name and same path. If the STL matches, then there is no problem. It is the current and up-to-date latest data file. But assume that I have replaced some old one. Yes, this is the backup. Now there is a mismatch. This STN is nothing but, what is STN? STN stands for system change number, which is nothing but a timestamp. It is nothing but int version, integer equivalent. Integer equivalent of timestamp. This timestamp only. This is old timestamp. So this means what? Oracle will not open up this those error because a file is there, but it is old. This requires recovery. So this is old STL, old timestamp. All the changes made from here, everything up to here has to be applied. Then only it becomes current. And where are the changes? To log file, RK log file. So you can restore a backup and recover. So the control file not only keeps track of where the data files are there, along with that, it will keep track of their latest STL. So a control file, if you have not understood this, don't worry, I will be repeating it again. But initially, I want to give you one liner. So control file keeps track of, keeps information about other files, and also there SCN or SCN system change number. So we cannot pull Oracle. It knows is this correct or wrong. So it matches and it keeps updating both. That is control file. But how when as a DBA, my command is only simple startup. Okay. So first it has look for control file. Once it finds the control file, it will find other. But how it will know where is the control file? Where is this control file? Where to look for control file? So that information is stored in a file called as the SP file, server parameter file. In server parameter file, it's called as server parameter file. So there are many parameters. Parameter 1 equal to value 1, parameter 2 equal to value, something like this, which we will cover as we go. There is one parameter called as control underscore file. Here is the way we give the name and location of the, say for example, Wipro db.ctl. So this is the control file. So first, when you start up the Oracle database, it will read the SP file. SP file. By reading SP file, it gets to know where is the control file. Now once it opens the control file, it knows how many data files are there and how many log files are there, where they are. It will open up those. So sequencing is what? Sequencing is first SP file, then control file, CTL, then data files and redo log file. This is the sequence. But how it will know where is the SP file? There is a default location. Default. No need to tell where is the SP file. So that it will be there in Oracle Home. Okay, I'll show you where is the location. There is a default location. So simply if I say startup, it knows where to look for. There is a default. It should be there with this name here. So it will look for it and open. No need to tell where it is. But assume that we are not placed this SP file in default location. We have to start up C file equal to whatever is the file name with path. So this is called as, say for example, Wipro ORCL, SP file ORCL, SP file Wipro .org. So here I'm telling about start up the database by reading this. There is no ambiguity here. So it reads this By reading this, it will come to know where is the control file. By reading control file, it comes to know where is data file. All data files. So every time we start up, this is the sequencing. So these are the physical files. It has to read it. Server parameter file, it has to read control file, and then open up the data file and read log file. So we are now talking about physical structure. So here in this, we have not yet talked about many things. Data files we talked about, control files we talked about, redo log files we talked about, both redo log files we talked about, online and archive. And backup files we talked about. Backup files are backup of this. Parameter file we talked about. This is called as the SP file I was telling, no, SP file. Parameter file is we talked about. But what we not talked about is password file. This is to authenticate database administrator. Anyone and everyone should not be able to start up the database, no? So once the database is up and running, see here, I am the ordinary user, database user. I will say Vijay, I will connect as Vijay. I want to access the database. So in Oracle, there is a table called as DBA underscore user, the database user. So while I am connecting, it checks is there a user account by name Vijay or not, whether the password is matching or not. The authentication happens by the database, because the database is only when the database is up and running, the database user can connect. So all other users are authenticated by database. But who will authenticate DBA? Now the data, I want to start up my database. The privileged user who can start up the database and do a full-fledged administration. When database itself is not up, how can it? First, somebody has to start, right? So that is called as password file. The password files are the password file and are stored for the sys system. There is one super user called as this. The sys is authenticated through password file. So while suppose now my database is down, I want to start up. First, I have to connect. And to connect, this is the username. Everybody knows the super username is this, but password, I will give password. I may then check is the password correct in the password file. If it is correct, it allows you to connect. Once it is connected, you can start up the database. Once the database is started, others can connect. This password file is not the password of all database users. It's only for DBA users or privileged users, who can administer the database. Okay. So this is password file. And there are a lot of, there is a crash, instance crash. Okay. Why it crashed? That log has to be generated, right? So those logs will be there in alert log file, and is not only error, every activity. Now I started up, done. That has to be recorded at what time the database instance started. I normally shut down, there is no crash. I am doing a major database administration task. That alerts has to be logged. That there are files called as alert, log, and trace file. Alert, and not only the activity, major activity, errors also, instance crash. There is a block error. The block got corrupted. I am running a query, it throws an error because it's reading a corrupted block. So that information has to be logged in alert file. So it's a very important file for database administrator. If anything goes wrong, we can check what is the that alert, will be there here. And that alert says that the detailed information about these are available in the trace file. Okay, you will get some information about the problem and then detailed problem analysis. These are the physical files involved in a database. So we know these are the files. So for today, okay, anyway, I'll take some more. So now let us do little bit of hands-on now. So today, last half an hour, or if not half an hour, now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have any questions, please speak, because I may not keep observing the participant window. So if you have any questions, please, I hope all of you are using the chat window. It's a very effective way. You can just mention I have a question or something like that. Okay. So So any questions as of now in this slide? So I have just given one liner of what is data files, what is redo log files, what is their purposes.
No, for me. It's okay.
That's yeah. Okay. Now too much of theory, continuously talking, and you maybe it may not be, you may not be able to recollect, connect. So what we will do, we'll do hands-on. So now what I'll do is I'll go to the command prompt. Is my command prompt visible?
Yeah.
Yeah. So now fine. So now I want to connect as a super user. So every time you create a database, a user gets created, a user with name sys. This is a supermost user. There is no user above that. Sys can do everything. Can start up database, can shut down, can create other users, can create tables, every operation. Okay. And the password of that sys is authenticated by password file. Okay. So I'll go and show you the files on the actual storage. Just give me 1 second time. This is the Oracle installed on my laptop. Okay. So 1 second. I have multiple databases. See, these are my data files. You can observe here .dbf, 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 the ones which are ending with .dbf are data files. The one which are using with redo.1, this is called as redo log file. These are called as online redo log files. There are something called as archived, which I show. This is the control file. This control file has information about the data files and redo log files. So for our training now for laptop, all files are systematically there in just one folder. All files are all data files, redo log files, control files is there in only one folder of one database. This is one data. This is the name of the database, non-CDB. Name of the database is also non-CDB. The folder name is also non-CDB. So this is only in training environments and learning purpose. Actually, in the production, only there will be one point. They will be scattered across multiple. But anyway, files are there. Okay. Apart from this, so these are called as archived redo log files. These are archived log. So the day-wise archived redo log files are there. They are very important for media recovery, and backups are there. Which I will cover. Then I was telling you something called as 1 second. Okay, anyway, what is that? Oracle Home Network. Just give me 1 second. See, I was telling you, this is network related files. Listener and TNS. I will talk about that later. Okay. So now, so anyway, I will show you. So these are the files on the storage actually, no? So we will do something, some hands-on we will do. So what is that hands-on I want to show you? Now I want to connect to the database. So I am using a tool called as client called as SQL plus. SQL plus. I log in as sys. What is the password for sys? /password. It says only. In my case, in your machines where Oracle is, password is different. I'll share the password. But sys always has to connect with a privilege called as sys DBA. As sys DBA, system DBA. This is called as a very powerful privilege. Okay. Now I will purposely give wrong password here. Enter. This is invalid username. Username is correct. Password is wrong. How it knows the password is wrong? It has checked in the password file. It has checked in the password file. If I give the correct password, I will be able to connect. So in my case, I have connected to what database? Tulsi database enterprise edition. What is the release? What is the 60-bit the production? This is the database which I have connected. Now, how do I know my database is up and running? or it's yet to be started? If it is yet to be started, you get a message called as connected to idle instance. Idle instance. Connected to idle instance. Idle means what? If the database is not yet started. Then I will give a command startup. Simple startup. But in my case, I cannot start up. It's already started and running. But how do I know whether it is running or not running? If running, in what state it is? So for that, we have a lot of Oracle stuff. I'll tool it. So now whatever I'm doing, no need to write down. There is a command called as tool. E:\\, what is today's date? 19 underscore the first file dot txt. So there is whatever I do, everything will be there in this file, which I will share with you. So now we were talking about the database is made up of two components. One is database itself, other one is instance. So is my instance open or not? How do I know? If there are data dictionaries called as describe $instance. This will give me the information about instance. What is the name of my instance? Name. Which version? When the instance was started up? What is the current status of the instance? Okay. So much of things. We will not get into too many things immediately. There are so many columns, but I am interested in what is my instance name? Instance underscore name, comma status. This is important for me. From $instance. Okay. Spelling mistake. Instance underscore name. See here, in my case, the instance name is non-CDB. Why did I call non-CDB? I'll tell you later. But you should be giving proper name. Whatever by default, whatever database you name, the instance name is the same. So open means it is fully open. The end user, database users can connect. But there are other statuses which we will discuss. The other status is called as no mount, open. The instance can be in no mount stage, mount and open. Open means it is open for everyone. Okay. The instance is open. The instance accesses the database. Through the instance, we access the database. So I want to know the information about the database. Instance is running in memory, which is accessing the database. So for that, we have another data dictionary called as $database. So this is giving me complete information about my database. What is the name of the database? Every database has a unique DB ID. When was this database created? Okay. And what is the open mode? Instance is open, but what is the database is opened in which mode? Is it open in read-only mode, or is it open in read-write mode? If it is open in read-only mode, only queries can be executed, select statement. But if it is open in read-write, it is applicable for everything. And there are many other columns. Purposely, I will not get into all that in first case. So now I am interested to know what is the name of the database name and open underscore mode. You can explore other columns from which data dictionary? $database. See here, the database name is also non-CDB and it's open in read-write mode. Read-write mode. It is open in read-write mode. So this is normal mode, right? Normally, the database is read-write. So what is the meaning of that is the database is fully up and running on the server. Users can connect, can do insert, update, delete, create, alter, drop, everything. Because based on their privilege, it is open in read-write. Now I can shut down this, and while opening, I can open read-only mode or read-write mode. Now it is already it is up and running. So we will see how do we shut down and restart. And also we know the information about database, but the database has different types of files. So where is my SP file? Where is my how many control files? Actually, control file I will just tell you. This control file is just one file only, which has information about other data files. But what happens if the control file is lost? If you run with a single control file, see what is most important. See, actually you may have all data files and doodle files in place, but Oracle will not know how many are there. That information is stored in control file. If control file is lost, Oracle will not be able to find out where are the data files. So for that purpose, what we do now, we multiplex control file. That means mirror. This repro is there. I have this is one. I have another copy of it. Two. I have another copy of three. They are always plus. That means when Oracle writes, Oracle keeps all of them up to the same thing. Whatever it writes. The advantage here is if accidentally one is lost, there is no problem. You have the other one. So you should, on the safer side, there should be more than one control file on different disks. So we will see all that. So how do I know where is the SP file? For that, there is a command called as show parameter file. Tells you for this database, the SP file is this position. SP file non-SP. The database. Typically the SP file. So while starting, first it would have already read this. By reading this, it would have come to know where is the control file. So now I see here, describe v dollar control file. So I'll know where is my control file. Name of my control file. Select, and whether I am running with one control or here also you can say show parameter control underscore file. Here this you can observe here. This is good one. Show parameter control underscore file. So you can hear control01.ctl, control02.ctl. Actually, both are in sync always. But why do I have whatever information that is stored here, the same information is stored in this? Why 2 is for fault tolerance. And actually, in my training environment, both are stored on the same disk. But if the disk now actual purpose of having is to for fault tolerance. If my C drive crashes, both are lost. But actually, in production, it will not be so. One will be there on one hard disk, the other will be there on the other hard disk. The advantage of that is if one is lost, the other is there. But while Oracle writing, Oracle writes to both. So good to have. Nothing wrong in with running with only one. If that is lost, it's problematic. There are ways to recover, but it's tedious. So when things can happen easily by taking some precautions, it's always, suppose say I am a Oracle DBA for this database, and if I see only one control file here, immediately I should do the multiplexing. To be on the safer side, I may want to have at least 3 control files on 3 different disks, so that I am safer. My database is safe. If one is lost, the same information is there in the other. Okay. So that is called as multiplexing control file. What we'll do as part of our hands-on, assume that we have only one. We have 2, but I want to have one third one also. Control 01, control 0. I want to have control 03. How do we do? That we will learn later. Okay. So select name from v dollar control underscore file. So no, not underscore, control file. So these are called as control file. These are the control files. 2 are there. They are not different. They are in sync with each other always. They are copy of each. 2 copies to be on the safer side. So while reading, Oracle will read from only one because both are same. Whether it reads from here or reads from here, it doesn't make any difference. It will always read from the first. But while writing, it will write to both. Okay. So now we know where is our SP file. We know where is our control file. Now, how do I know how many data files are there and where they are? Data files information I want to capture. For that, describe $3 data file. It gives the complete information about how many data files are there and where they are. And every file has a unique file ID. And file actually belongs to table space. What is a table space? It is a collection of related data files. So, what is the size of the file? Bytes. In terms of bytes, in terms of blocks. What is block size? What is the name? It's as we proceed. So simply select name, comma, file ID, comma, TS number from $v data file. It shows you so many are there. So this is called as, this is one data file name with path. The file ID is 1. It belongs to table space number 01. This belongs to table space 1. This belongs to table space 2. The file belongs to different table spaces. So now we are able to get this database has how many data files and where they are. Actually, Oracle is getting this data from control file. Okay. Now describe $v table space. Table space. It tells you TS number, comma name from $v table space. So now actually I want to know this file belongs to which table space. So in $v data file I have the file name and table space number. Here I have table space number. So I have to do a join of these two. What is the common column? Table space number here, table space number here. So I get to know. So now very, very simple. This is the system table space. How many files are part of this table space? How many files are here? I have to do a join. You know already joins, right? So you have to join these two to get the complete information about table space and their data file.
May please, sir.
So what is this system table space is an system exclusively for Oracle supplied data in multiple data files. The user, something like some. So we can create our own. Suppose say now there is a new application coming up for travel related. So I don't want to mix that everything. I'll create a table space by name travel with one data file. I create a table space by name travel TS with one data file. When that data file is full, I'll add one more data file. When that is full, I'll add one more. So a table space is logical, which consists of one or more than one data file. So that's one. So with that,